In testing the truthfulness of his students, the statistics professor had two competing claims. On the one hand, the students could have just been guessing which tower is flat, so basically their story was a lie. On the other hand, the students are not just guessing. Their story was not a lie and they had a valid excuse for missing the final exam. So we call that first part, the H naught, we call that the null hypothesis, and HA is called the alternative hypothesis. Hypotheses must be written in such a way that they are both quantifiable and testable. That way we can distinguish which hypothesis is more likely to be true. So in this case, we want them to be quantifiable, testable. That way we can tell whether it's more likely that students were lying or students were telling the truth. The first one, H naught, is called the null hypothesis. This is the claim that the population parameter has a specific value. Thus, the null hypothesis will be written in this form of H naught is equal to parameter equal null value. Parameter is just whatever value we're trying to find from the population. It could be a mean, could be a proportion, could be just about anything. But whatever we're looking for is equal to some specific number. And that specific number is what we call the null value. Technically, you can also write this with less than equal to or greater than equal to, depending on the claim. There's no advantage of doing so. So for every hypothesis test you see for this quarter, we're going to use equals for the null hypothesis. Some examples. H naught, the null hypothesis, is that the proportion is equal to 40%, or whatever the mean is 200 pounds. The difference is 0. That is, there's no difference between the two groups in this case. You could also test whether the interquartile range is 30 meters, or maybe whether the maximum is 10 seconds, or whatever parameter, whatever value you're looking for, you set it equal to some value. Again, the null hypothesis is always in the form of some parameter equal to some value, and that value we call the null value. The competing claim is called the alternative hypothesis, and this is basically the researcher's hypothesis. It is usually a statement about a value of the parameter that we hope to demonstrate to be true. So this is the hypothesis we're trying to prove. For most of the quarter, the alternative hypothesis will generally be written in the form of wherever the parameter is not equal to some null value. So it's actually the opposite of the null hypothesis. And again, we could use less than or greater than, and for the two previous lessons we were, but essentially from here on we're going to be using not equal to. For one thing, it's more scientific. Some examples of the alternative hypothesis. Well, one type of alternative hypothesis, the proportion is not equal to 40%. Or maybe we want to show the mean is not 200 pounds. Or that the difference is not 0. That is, there is a difference between whatever the groups are. Perhaps we want to show the interquartile range is not 30 meters, or the maximum is not 10 seconds. Again, it's pretty much like the null hypotheses, except we're going to use not equal to. So again, the alternative hypothesis will be written in the form of some parameter not equal to the null value. So for our class, when you're asked to write hypotheses, it'll generally be written in this form. That the null hypothesis will be in the form of parameter equal to some null value. The alternative will be the parameter not equal to some null value. So again, the alternative hypothesis can also be written with less or greater. However, not equal to is usually the better choice. If you have after we show the alternative has got to be the more likely hypotheses, then we look to see whether it's less or greater. But until we prove the alternative, stick with not equal to. Alright, so some examples. Suppose here we have the governor claims the percentage of adults over 25 who graduated from high school is greater than 85%, the national average. Well, I'm looking at this, so if you want to try to prove this statement, we are looking at proportions here. Here it is. So we have done with 85%. This is a proportion. So, and this is what we're trying to prove, so we're going to set this as the null value. That's going to make my claims. The null hypothesis will be the proportion is equal to 85%, and the alternative is not equal to 85%. Again, the way hypothesis test works is, let's try to prove it's not 85% first, then we'll worry about whether it's greater or less than 85%. Alright, the Food and Drug Administration claims that the amount of vitamin C in tablets produced by company is less than the advertised 500 milligrams. Well, in this case, if you want to use an hypothesis test, most likely you're going to be dealing with averages, or the mean. The null value is at 500. So we can set this up that the null hypothesis is that the mean is equal to 500 milligrams versus the alternative that the mean is not equal to 500 milligrams. And again, prove the alternative is true first, then worry about whether it's less than the advertised 500 milligrams. Let's see, we want to test that the average college student takes less than 5 years to graduate from college. We're looking at this. I see the word average should be kind of a clear clue that we're dealing with means. We want to be less than 5 years, so that's the null value will be the 5 years. So mean equal to 5 years versus the alternative not equal to 5 years. Let's see. The director of public works for a small town claims that the mean water usage among households exceeds 1,675 gallons per month, the level required for the water supply to last through the year. So right away, I see the word mean. So that's going to be my parameter. Null value is at 1,675 gallons per month, where we want the mean to be less than that. So my hypothesis, the mean is equal to 1,675 versus the alternative, the mean is not equal to 1,675 gallons. All right, 2 more. The manufacturer of a new car model advertises the car averages 38 miles per gallon on the highway. So again, it's another mean. Consumer Group says this claim is overstated and that the actual average is less than 38 miles per gallon. So once again, parameter is mean. Null value would be the 38 miles per gallon. So mean equal 38 versus mean not equal to 38. All right, one last problem. A candidate for Congress claims to have a majority of the popular vote. Her opponent claims otherwise. Well, the word majority is when the percentage is more than 50%. So this is going to be a proportion, and the null value is 50%. So the null hypothesis is that the proportion is equal to 50%. Alternative is that the proportion is not equal to 50%. And then once more, prove the alternative is true first, then worry about whether it's greater or less than 50%.